Hello, grade 12s. My name is Unami Jengeta and welcome to Amelia Academy. Today we'll be doing functions, grade 12s. Please, if you haven't joined our membership, or if you haven't subscribed yet, please press the subscribe button. It would definitely mean a lot to me. And you can also like and share to anyone who needs to hear this, or who might find this lesson valuable or important. And please, if you feel like you need extra lessons from this, please feel free to take my contact details from my profile. Okay, so today we'll be doing functions. Okay, what is a function? What is a function? Function definition simply says that for every x value, there is one y value. Okay, I'm sure you can remember that from the lower grades, or grade 8, grade 9, where we used to illustrate functions in the form of a table like this. Sorry. Okay, I hope that's clear. We have your x on top and your y on bottom. Okay, which is 1, 2, 3, 4 would be your x values. And if you're looking for y value, you have to use the general rule. At that time, it was in the form of y is equal to mx. Okay, or maybe I can just say, like, you will be given a rule whereby you have to insert an x value in order for you to get a y value. Okay, so let's say that y is equal to 2x, and then in the place of x you have to put these top values. So if you put x here, so it's going to be 1, y is equal to 2 times 1, which will be 2, and 2 times 2, 4, and 2 times 3 is 6, and 2 times 4 is 8. And these are coordinates. And then you have to put these in a coordinate form. Okay, like 1, 2, 2, 4. And you know that this is your x value and this is your y value. This is your x value, this is your y value. And these are input values and these are output values. Okay, for every x value there should be one y value. Okay, so we have different types of functions here in grade 12. We have your linear functions, be your parabola or quadratic function, and we have your C, hyperbola, and D, your exponential. Okay, let's start with linear functions. Linear functions, which are also called straight line graph. Okay, so a straight line graph is given in a form of y is equal to mx plus c. Okay, where y is your y-intercept, and m is your gradient, C also is your y-intercepts, or where the graph cuts in y intercept. Okay, and then this is your x-intercept. Okay, remember this is your y. Okay, so a gradient, let's start with the gradient. We have a specific way of calculating a gradient in the straight line graph. Remember, a gradient is a steepness of the graph. Okay, and here is a way of calculating y2 minus y1 is equal to x2 minus x1. All right, so in a straight line graph, if gradient is greater than 0, your graph will be increasing. And if gradient is less than 0, your graph will be decreasing. Okay, all right, so how do you see if a graph is increasing or decreasing? Remember, you read from your left to right. So if by increasing I mean it will slant slightly to the right. So when you read it from the left to right, so as you read from the left to the right, the graph is going upwards. That means it is decreasing. And then it is increasing. And then this one is decreasing. Obviously, you're reading it from your left. As you go to the right, it is decreasing. So that's how you see if your graph is increasing or decreasing. And then C, as I just said, that C is your y value or your y intercept. Okay, so now we're gonna have to sketching or drawing a straight line graph. Okay, so let's make an example. Let's say there is a question which says sketch the graph of f at x is equal to 2x plus 4. Okay, f at x is equal to 2x plus 4, right? So first things first, remember f at x is your function format. Instead of y, we say f at x. Maybe any alphabet, can be your t at x, can be your g at x, your j at x, any alphabet. All right, so steps of sketching any graph or any function here in grade 12. Firstly, you have to determine the gradient. Okay, so how? I said if your gradient is greater than 0, your graph should be increasing, right? If your gradient is less than 0 or negative, your graph should be decreasing. So we can see that here in this general rule of format, this is your gradient, right? mx plus c. This is your gradient, and your gradient here is positive. That means it is greater than 0. That means your graph, you're expecting your graph to increase. So this 2 only tells you that if your graph will be decreasing or increasing. Okay, number 2, step number 1, step number 2, find your intercept. Find your x and y intercept. All right, for x intercept, you make your y equal to 0, and for y intercept you make your x equal to 0. How? So here is your formula. F at x is equal to 2x plus 4. Okay, you're looking for an x-intercept. Sorry about that. Remember, I said that this is the same as y is equal to 2x plus 4. All right, so you make your y be equal to 0 and solve for x. So it will be 0 is equal to 2x plus 4, and then you transpose this 4 to the left hand side, and it will be minus 4 is equal to 2x, and then you divide by 2, and then your x will be equal to negative 2. All right, and then for y-intercept, x equal to 0, right? So again, you write your formula. Okay, and then this is your y. Y is equal to 2. You make your x equal to 0. Sorry. And then y will be equal to 4. Remember, 2 times 0 is equal to 0. Okay, y equal to, so y also represents a c. Remember, I said that your x-intercept is where your graph cuts at x-axis, and your y-intercept is where your graph cuts at y-axis. And now you can sketch your graph. Okay, remember, when sketching it, you have to make it in scale, or just for it to be neat and clear. Okay, remember, in the horizontal line we find your x-axis, and the vertical line we find the y-axis, and here is the origin. What does origin mean? Your point here is 0 of 0. Okay, so for in this line, your your y will be 0, and then in this line your x will be 0. So this is 0 and 0. All right, okay, so you already know that your graph is increasing, but it will just like come out as it is. So your x, you've calculated your x is -2, and your -2 is expected to be on your left. Okay, and I'm gonna say -2 is in this position. Obviously you have to measure it when you're drawing, and make sure that the spaces in between the numbers are equal for your graph to be accurate. Okay, I will say this is my -2, and y is +4. Sorry, +4. Positives are upwards and negative downwards, negative left and positive on your right. Okay, and then you join the lines, the dots. Okay, as you can see, my graph is increasing. You're reading it, remember, you're reading it from your left hand side. So as you go to the right, the graph is going up. That means it is increasing. And then you label your graph. Okay, f at x, this is the graph of f at x, is equal to 2x plus 4. All right, okay, so let's say you are not given an equation. Okay, there's 2 ways of finding an equation in a straight line graph. What equation are you trying to find? That's your y is equal to mx plus c. or your f at x is equal to mx plus c. Remember, other books use y is equal to ax plus q. It's the same standard format. It's just that they're using different letters. Okay. Given 2 points. 2 points. So finding an equation of a straight line graph, obviously in a form of f at x is equal to mx plus c, or y is equal to mx plus c. There are 2 ways of finding a graph. They definitely have to give you 2 points for you to find a graph. So when you are given 2 points of finding an equation of a straight line, you first have to find the gradient. You find the gradient. You find the gradient. Obviously, I have given you the formula of finding a gradient. M is equal to y2 minus y1, x2 minus x1, and then you substitute the values. You're gonna take b. This is point B. You're gonna take B as your x2, y2, and A as your a2, y2. Obviously, it makes sense because B comes after A. So firstly, A and B comes after. All right. So which remember, it's your x, it's your y, it's your x, it's your y. So which one is y2? It's your -4. Which one is your y1? Minus for the formula of -3. All right, and divided by x. Which one is your x2? It's 7. Minus which one is your x1? It's 5. All right, so -4 -4 into -3. Remember, a negative times a negative is a positive, so it's gonna be -4 plus 3, which will be your -1. All right, and 7 minus 5 will be 2. Okay, so now that you got the gradient, you can take any point here because you only have the gradient. You don't have your y-intercept, you don't have your x-intercept. So you can take any point here and you replace it in your formula to find the value of c. So f at x is equal to mx plus c. You already have your gradient, so by now you should know that your graph will be slanting downwards. That means it will be decreasing. So let's take point A. Let's take point A. All right, so you replace it here. You want to find the value of c. You want to find c. Okay, remember I said that f at x is exactly as y. So which one is y here? It's -3, and your gradient it's -1/2. And which one is an x value? It's 5, and you want to find c. All right, -3 is equal to 1 times 5. Remember, a numerator with a numerator, a denominator with a denominator when it comes to multiplication. So 1 times 5 will be 5/2, -5/2 plus c. All right, so you transpose -5/2, it will be +5/2 is equal to c, and then you take your calculator. You take your calculator and punch -3 plus 5/2. That will be -1/2. Okay, -1/2 is equal to c. Right. Okay, now that you have found the value of c, and then what happens, you have to come back and substitute those numbers. Remember, you just found the value of c. These are not the exact points of an equation, so your f at x is equal to mx plus c. F at x, remember you already have your gradient, which is negative 1 over 2 x, and then your c in this case is negative 1 over 2, and then here is your equation of the graph. Okay, and then with a gradient of negative 2 and point 1 over 2, I mean 1 is to 2. All right, and you already know that, okay, you don't know, there is a formula for calculating an equation of the line when given a gradient and a point. It's your y minus y1 is equal to m into x minus x1. All right, okay, this is one is quite easier, so you use the point. Okay, this will be your x1 y1, so y minus, which one is y1 is 2, is equal to your gradient, and which one is x1 is, I mean it's x, which one is x1, it's your 1. All right, and then y minus 2 is equal to negative 2 times x is negative 2x, negative 2 times negative 1 is positive 2. All right, and then you transpose, because you want y on the left hand side, so that it can match your standard format y is equal to mx plus c. So you're gonna say y is equal to negative 2x plus 2 plus 2, this 2. All right, y is equal to negative 2x plus 4. Here is your equation. All right, they will only say that when there is 2 or more graphs in a Cartesian plane, so that means their gradient is the same, or a gradient is the same throughout the point. If they tell you that a gradient is parallel gradient, that means gradient is the same. And then for parallel gradient is the same throughout the points. And then for perpendicular gradient, okay, gradient m1 times m2 is equal to negative 1. Okay, they can also ask you to find an equation of the graph if the graph has a parallel gradient or a perpendicular gradient. This is what they will mean. Okay, and then you have what we call as your domain and range. All right, domain and range. This means that domain is your possible x values, and your range possible y values. So domain is given in this format. X is an element of real numbers, or y is an element of real numbers in straight line graph. Okay, so okay, grade 12s, that's all for straight line graph. I'll be checking out the questions for you, and I will be doing them on my next video. And on my next video also we'll be doing quadratic functions. And please you're welcome to come and watch anytime you need. And please do not forget to subscribe for my channel, as that will mean a lot to me. Goodbye. Thanks for watching.